Hi, my name is Lucas Rossato Rocha. I'm a postdoctorate researcher at Federal University of Santa Maria, Brazil. Our research is entitled Sensorless Control of Non-Sinusoidal PMSM via Sliding Mode Observer and PSD+PLL structure. Today, we face an unprecedented environmental crisis. Greenhouse gas emissions from fossil fuels keep rising, worsening global warming and accelerating environmental degradation. To ensure a sustainable future, we need cleaner, more efficient and accessible energy solutions. In this context, we work at Federal University of Santa Maria. Our graduation program, Electrical Engineering, is ranked among the top 5 in Brazil, with strong research in intelligent systems, power electronics and renewable energy. Here, we develop technologies that support the global energy transitions. We work with transport electrifications, renewable energy integration, and control of power converters. I'm a member of GEPOC, the Power Electronics and Control Research Group, which has been contributing with innovative power electronics solutions for over 3 decades. Here, we are specialized to develop inverters for photovoltaic system, EV chargers, converters for microgrids, and EV traction inverters. This year marked a milestone as we completed a project in which we fully designed and built an electric powertrain. Following this milestone, our efforts have expanded towards 3 new projects focused on the design and construction of electric powertrains. My research focuses on the development of control techniques for non-sinusoidal PMSM, with particular focus on torque ripple reduction and sensorless strategies. In our work, we proposed a sensorless strategy for non-sinusoidal PMSM, which allows to reconstruct the BEMF via super twist in sliding mode observer, and furthermore extract the fundamental frequency using dual second-order generalized integrator and positive sequence detector, from which the rotor speed and position can be estimated via phase-locked loop. With this, we aim to improve energy efficiency and enhance the reliability of embedded systems in electrical vehicles. Attending IECON2025 is a unique opportunity to present my work and learn from researchers around the world. Thank you IEEE Industrial Electronics Society and young professionals for this opportunity.